Thank you.
All right, so we're doing tangent, cotangent today. We're going to find all these parts over here on the right, and we're going to graph them, and we're going to do all that stuff. So again, I wrote all the sine, cosine stuff we've already done. The big deal here in red, the pi over b period is different. Period over 2 pi are the intervals. That's your tick marks. Remember the tick marks we make on the x-axis? We're going to make those by taking whatever we find for the period, divide that by 2. And now if you do cotangent, the y-axis starts as an asymptote. That's why I got this asymptote written here. So the cotangent goes asymptote 0, asymptote 0, asymptote 0 forever. Now how that's different from tangent? The y-axis, you have a 0 first, the origin. The tangent goes through the origin first, the 0, just like sine did. So when you do a tangent graph, it goes 0, asymptote, 0, asymptote, 0, asymptote forever. And the other big deal is cotangents are always decreasing, tangents are always increasing. All right, and the vertical shift, the phase shift are always the same. So I need you to make sure when you get home, you can translate what all these symbols mean for domain here. So brace, that brace right there is read the set of. That's a set notation, the set of. Down here for the range, that's interval notation. So this first part, where you get just to the R, I'm going to read just to the R part. It is the set of X, and then that slash mark are the words such that. Mr. Tamby, come with me, man. Write down that this means such that. The set of all values X such that X, and now it kind of looks like a C with a little line there. That is actually an E. And that stands for is an element of. Is an element of. And then this crazy R that's got two posts in it, that's supposed to be an italicized R. That R stands for real numbers. That R stands for real numbers. So I'm going to ignore the except the rest of it right now. Ignore the rest of it for a few minutes, a couple seconds, 2 minutes, I don't know, whatever it takes here. If I said the set of all numbers such that X so that X is such that X is an element of all real numbers. Can anybody tell me what that means in interval notation? This kind down here. X such that X is an element of all real numbers. Can you tell me what that would be in interval notation? It's the same thing right there. Negative infinity to infinity. That's what that means. This part up through the R means that X can be all numbers, all real numbers. Mr. Downing's friends are the only ones that can't be the square root of a negative imaginary. But this means X is all numbers, which is negative infinity to infinity. So that and this mean the same. And then I put the key word in there. Except. Now comes where it doesn't work. So we're saying all numbers work except, and then it's going to be X equals an asymptote. So we're going to put down a number here. So you're not going to write the word asymptote. We're going to put down where the asymptote is. And then we're going to write down plus 2 times the intervals, which is right up here where it says period divided by 2. We're going to take 2 times that. And then times K. And then we say where K is an integer. Can anybody in here tell me what an integer is? All my classes but one, somebody could tell me. Anybody in here tell me what integers are? We've talked about them this year. Anybody got a guess? Or you can just be wrong. Yell out if you got a guess. We're going to stand here and look at each other for a while if you don't. What? It is numbers, but it's specific numbers. I need you to narrow down what kind of numbers integers are. All numbers are real except the imaginary ones. The square root of 2 is a real number, but it is not an integer. Okay, rational numbers. Anybody know what rationals are? What are they? You can write them as how? What? Well, if they're decimal, they can terminate or repeat. But rational numbers are numbers that can be written as a fraction. Okay? 1/2 is a rational number, but 1/2 is not an integer. So rationals are not the right word. Imaginary? Is that what you said? That's Mr. Downing's friends. Those don't work. Irrational. That's square root of 2. They don't work either. They're not integers. Does anybody remember Bobby talking about you going to grandma's house? What's the first set of numbers? Anybody remember?
Positive.
Did you say confident?
Positive.
Okay, right. Where did you start?
1.
1, 2, 3, 4. What are those called? Starting at 1. 1, 2, 3, 4. What are they called?
Integers.
What kind of numbers? They got a special name.
Integers.
They are a part of the integers, but there's more than those. They're called the what?
Real numbers.
All these we're talking about today are real numbers.
Whole numbers.
What did your mom tell you to do for your grandma? Show grandma how smart you are. Do this.
Count.
Counting numbers. 1, 2, 3, 4, they're counting numbers. Now, the real name, besides counting, are natural numbers. So if you had a capital italicized N, that stands for natural numbers. Okay, that's the first set of numbers, the naturals. Then we put this number in there. What number is that? 0, that's a whole new set, just by adding 0. Anybody know what those are called? Somebody said it a minute ago. Starts with a W.
Whole.
Whole numbers. 0 and the naturals are whole numbers. Now the next set are integers. Anybody know what we threw in there with all those 0, 1, 2, 3, 4, 5? Negatives. Those are the integers. Negative and whole numbers. Whole numbers and their opposites. Those are the integers. No decimals, no fractions, integers. Those are those. Did you all write that down? Because you're supposed to know that. Okay, so integers mean no fractions, no decimal, whole numbers and their opposites. 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, forever. That's what integers are. Okay? So I'm going to show you in a little while when I do example 21 how this gives you all the asymptotes. Okay? Anybody got any questions on it? How many of you are thumbs up on the notes part? You guys want me to go over all the numbers? You want to go over all the number groups? Okay, we're not going to then. You're supposed to know them all. If we got time later, we will, but I don't think I have time now. All right, I'm going to pause this because I've already done the next 2 problems on video, and I've already put it on